Hello, sweet friends. Welcome to Chapter 11B, Surface Area and Volume. We have finally made it to our three-dimensional shapes. We have spent so much time recently on area and perimeter. So perimeter was one-dimensional. Area was two-dimensional. We have finally made it to our 3D shapes. And so what we have on here for your packet, we have the formula sheet for surface area and volume formulas. Some of the different shapes we're going to be looking at are prisms, cylinders, pyramids, cones, and spheres. SA stands for surface area. So these are all of our surface area formulas we're going to be looking at the next 2 weeks. And then we're going to cover all of the volume formulas as well. So surface area is like how much cardboard does it take to actually make the box. Volume is how much stuff can you fit in the box. So think about Amazon when we're thinking about surface area and volume. There are a few formulas that are not given on the ACT, but definitely you need to know. So some of those formulas that you're going to need to know from the last chapter are area of a triangle is base times height divided by 2. The area of a rectangle or parallelogram is just base times height. And then our classics, our circle formulas, twinkle, twinkle, little star, circumference equals 2 pi r. And fuzzy wuzzy was a bear, area equals pi r squared. So just things you need to know this chapter. Our very first lesson is going to be 11.4 three-dimensional figures notes. So we finally are going 3D. And so remember we said that whenever we get to our volume is going to be units cubed. Our surface area is going to be units squared still, but we are starting to look at shapes that are three-dimensional. So not only do they have a length, a width, and a height. Okay? And so let's start to investigate those. Our homework is going to be a Google Sheet. Miss Mayhew is fabulous. She made you all a Google Sheet that whenever you put in the right answer for your homework, it turns green. There's some conditional formatting that makes whenever you put in the wrong answer, I believe that it turns red. So we want those turning green, and that's a really good way to self-check. All right, so what is a polyhedron? We know that a polygon is a 2D figure with flat edges, flat sides. But today we're going to be looking at 3D figures. So a polyhedron is going to be a 3D figure whose surfaces are polygons. So all of the surfaces in the shape are going to be polygons. So what is a face in that polyhedron? It is going to be a flat surface. Our faces are going to be the flat surfaces in that shape. Of course, they're going to be made up of polygons. And so in my picture, this would be a face. Let's count how many faces we have in that shape. We have the ceiling, we have the floor, so that's 2. And then we have the 4 walls. So how many faces would I have in that picture? I would have 6 faces total. I'm going to go ahead and start practicing counting. All right, what about the edges? An edge is going to be a segment that is the intersection or the crossing point of 2 faces. So whenever I have 2 faces crossing, I get an edge, okay? So that is going to be one-dimensional. An edge is going to be the edge of something. Y'all have seen that before. You can look at the edge of your paper right now. An edge is going to be the segment that is the intersection of 2 faces. So how many edges would I have on this? Let's go ahead and outline them. 1, 2, 3, 4 on the top. Vertically, 1, 2, 3, 4 on the walls. And then 1, 2, 3, 4 on the bottom. So 4 plus 4 plus 4 is going to make 12 edges total in that picture. All right, now let's look at what a vertex is. We've got a plane, which is the face. We've got a segment, which is the edge. And we've got a point, that is the vertex. Okay? The vertex is going to be the point that is the intersection of 3 or more faces. So this point right here is where 3 planes cross. So I'd have 1, 2, 3, 4, 5, 6, 7, 8. So I would have 8 total vertices, that's the plural, 8 total vertices on this shape. Okay, so those are the pointy parts of the polyhedron. All right, so let's start by just counting some faces, edges, and vertices. How many faces live on this shape? We've got the floor. It's a triangle, so then I've got 3 walls. So what is 3 plus 1? I would have 4 faces on this shape. How many edges do I have? 1, 2, 3 around the walls, 1, 2, 3 are on the floor. 3 plus 3 makes 6. How many vertices do I have? They're at all the points, at M, at O, at N, and at P. So how many do I have total? I have 4 vertices on the shape. All right, what about this house? Y'all, we've been drawing these since we were little. I would have the front of the house and the back of the house. So that's 1, 2. And then I would have 3 on the roof, 4 on the roof. I would have the walls, 5, 6. Then I have the floor, 7. So I would have a total of 7 faces. Let's count our edges. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Let's double check that. So 4, I like to make notes. I like to go on levels. 4 around the floor, 4 around the walls. We have 1, 2, 3, 4 in the back. So 4, and then 5, 6, 7. So 7 plus 4 is 11, plus 4 is 15. So we do have 15 edges on this shape. If you needed to totally outline them, you could. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay? So it's kind of like if you were using sticks to build this house, how many sticks would you have? All right, now let's count our vertices. Those are the corner points. So 1, 2. Y'all, you can look at the letters. They already have the points there for you. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Are there 10 total? Let's count them. Okay, so 2 at the top, 4 in the middle, 4 at the bottom. So 2 plus 4 plus 4. Yep, that does make 10. So I like to go ahead and add those out in layers so I can count them a little bit easier. And so that helps me. Maybe it'll help you too. Okay? All right. Now, what if you can't see the back? So like right now, y'all, you've been drawing some shapes like this since you were younger. You've been doing this. And you're like, all right, let me draw a cube. And you do the dotted line to show yourself the back. We've been drawing those, sketching those since we were younger. But what if you couldn't see the back? There is a formula that you can use. This formula is called Euler's formula. It says that the number of faces plus the number of vertices, do that in yellow, is going to be equal to my number of edges on this shape plus 2. Okay, so F plus V equals E plus 2. My number of faces plus my number of vertices should be equal to my number of edges plus 2. So there's going to be times where you can't see the back. So like on this first one, you can see the back. If I were to count my faces, here are my faces. I've got the top, the bottom, that's a hexagon, so there are 6 walls. So 6 plus 2 makes 8. We can see our faces easily on that one. Now we've got my number of edges. Again, that is going to be 6 plus 6 plus 6. That is 18. Easy to see. Now my number of vertices on this one I can count. 1, 2, 3, 4, 5, 6 at the top. 1, 2, 3, 4, 5, 6 at the bottom. Okay, so it should be 12, but let's guarantee that with our formula. Our formula says that F plus V equals E plus 2. So E plus 2. Let's fill that in, use the formula. F plus V, faces would be 8 plus V equals E, edges, which we know is going to be 18, we've already counted it, plus 2. Well, what is 8 plus V? We leave that as 8 plus V. 8 plus V is going to be equal to 20. 8 plus V equals 20. And so, 20. And so if we wanted to know the number of vertices, we would just subtract 8 from both sides. So my number of vertices is going to be 20 minus 8. Well, what is 20 minus 8? That is going to give me 12. And so I found the number of vertices. Even though I couldn't see it, I could see it in this picture, the formula works out every time. So what about on this problem where you can't see the back? This is a polyhedron. I don't know how many sides it has. I actually don't know how many faces it has in general. But I know that it has 30 edges because they told me that. And I know that it has 20 vertices. So what I can do is I can use the formula. I can say, okay, well then F plus V, what is my V? My vertices are going to be 20. That should be equal to my number of edges plus 2. So E will be 30, and I get to add 2 to that. Y'all, what is 30 plus 2? That is 32. So I know that f plus 20 should be equal to 32. And so how do I get the 20 to the other side to solve for the number of faces? My number of faces is going to be 32 minus 20. What is 32 minus 20? That is going to give me 12. So even though I do not have it pictured, I can use the formula to find the number of faces. There would be 12 faces on this polyhedron. Same thing on this problem. I've got my number of faces. I've got my number of vertices, but we want to find my number of edges even though I can't see the back. So what we will do is we'll do faces f plus v equals e plus 2. Y'all know I love to color code, so if this is taking you longer, that is fine. E plus 2. Faces. Number of faces is 20. I want to fill in my number of vertices. My number of vertices is 12. That should be equal to my number of edges, e, that's what I'm trying to solve for, plus 2. I can't see the back, but this is going to become 32 equals e plus 2. How do you get the 2 to the other side? We subtract it. And so my number of edges is going to be 32 minus 2, which turns into 30. So I'm able to find a missing amount of edges, even though I can't see the back of the shape, using his formula. So that is Euler's formula. You can always use that, whether you can see the back or not. All right, now we're going to talk about naming shapes and then their faces, edges, and vertices, okay? So our prisms are going to be our polygon bases. Polygon bases. It has polygon bases, and you use the name of the base to name the figure. So if a prism has a circular base, it is going to be called a cylinder, okay? Polygon, let's say it's going to be, let's do this. It is going to be 2 polygon bases. Prisms are always going to have 2 bases. They're going to be polygons, of course, because it's a polyhedron. Use the name of the base to name the figure. So if a prism has a circular base, it's going to be called a cylinder. Okay, so prisms are going to have 2 bases. Let's go numerical there. That's going to be important. A pyramid is going to have 1 base, and all of the edges meet at 1 point. Use the name of the base to name the figure. If it has a circular base, it's going to be called a cone. Okay, so these are little, this is going to be, if it has a circular base, it's called a cylinder. If it has 2 bases, if it's a pyramid, it's going to be called a pyramid with a circular base is going to be called a cone. All right, and then we have something called a sphere. What is a sphere? A sphere is going to be a set of all points that are equidistant or equal distance, another way to say that, from its center. So every single point that is going to be the same distance away. It has no edges or vertices or faces. An easy way to picture this is a basketball. So every single point on the leather of this basketball is the same distance away from this point in the center of this shape. Okay, so if I put a radius all the way around the shape, all the way around, it would be the same distance all the way around. So there's no edges, there's no vertices, and there's no faces. And so what we're going to do now is we're just going to give some practice with naming shapes. And so a prism is going to be named by its 2 bases. And so let's look at this first one. The first thing I notice is that I have 2 of these faces are parallel. They're always going to be parallel. And so since I have 2, it's going to be called a prism. What kind of prism? This is going to be a triangular prism. Triangular prism. If you call it a triangle prism, that is totally fine. We're just trying to get those down. Okay, so how many faces does it have? 1 at the top for the ceiling, 1 at the top for the, 1 at the bottom for the floor, and then 3 walls. So a total of 5 faces. How many edges are there? Let's just go ahead and highlight those. 1, 2, 3. 1, 2, 3. 1, 2, 3. So 3 plus 3 plus 3 makes a total of 9 edges. How many vertices do I have? 1, 2, 3 at the top, 1, 2, 3 at the bottom. And so that's going to be a total of 6. If you wanted to verify, you could always use Euler's formula. F plus V is 11. 9 plus 2 is also 11. So I know I did it right. Now on this one, I have 2 parallel faces called the bases. And those are circles. And so I have a total of 2 of those, but I don't have any walls that are rectangular. So what do I call that? That is called a cylinder. Think of like a can of chicken noodle soup. How many edges do I have? Well, they're circular, so there's going to be 0 edges. How many vertices do I have? There's going to be 0 vertices because that is rounded. All right, what about this one? This one has 1 base. It is going to be rectangular, possibly, maybe a square, but I'm going to have that 1 base plus 4 walls makes 5 total faces. So I'm going to call that a rectangular. It comes to a point, so we're going to call that a pyramid. Rectangular pyramid because it comes to this point. How many edges do I have? Well, I have the 4 edges on the walls, 4 edges on the floor, and so that's going to be a total of 4 plus 4, which makes 8. How many vertices do I have? Well, we have the top point and then 4 points on the bottom, so a total of 5. Check your formula using Euler's. F plus V, 5 plus 5 should be equal to 8 plus 2, and it is. All right, what shape is my base now? The 2 parallel faces are going to be my 2 bases. Those are going to be hexagons, so we'll call this a hexagonal prism. If you call it a hexagon prism, that is fine for now. Floor and ceiling plus 6 walls is going to be a total of 8 faces. How many edges? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So 6 plus 6 plus 6 makes 18. But what about the vertices? 6 on top, 6 on bottom, those pointy parts. Y'all, there we go. 6 plus 6 makes 12 vertices. Again, check it. 8 plus 12 is 20. 18 plus 2 is also 20. So just some practice naming these shapes. This one, we've got what looks like our parallel faces, top and bottom. That is going to be a rectangular prism. Ceiling, floor, 4 walls. So 6 faces. Edges would be 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So 4 plus 4 plus 4 makes 12 edges. And then vertices. So 4 corners on the top, 4 corners on the bottom. Total of 8 vertices. Again, 6 plus 8 is 14. 12 plus 2 is still 14. We can't call that a square prism yet, just simply because we don't know anything about the information of the sides. Now, what is my next one? It has a circular base. So what is that called? That is going to be called a cone. So how many faces does it have? Just one. It's the circular face. And so how many edges does it have? It has 0 edges, and it has how many vertices? It actually does have 1 vertex. It's right here. It has 1 vertex. Okay? So the faces are defined as the flat surfaces. That does have a flat surface. That's going to be the cone. Let's go ahead and put that there. All right, and so it does have a circular base. That's one of my faces, but it has no edges, and it only has the 1 vertex. Okay? All right, again, we have another cylinder right here. It has circular bases, and so we're going to call those the faces. They're going to be 2. My edges, it's going to have 0 edges. There's no flat spaces, and there's no vertices. Okay? So circular faces, but it does not have any edges, and it does not have any vertices. Okay? All right, what about this next one? Well, this is a pyramid. How do I know? Because it comes to a point. The pyramids come to a point. Really easy way to remember that. Well, what shape is the base? The base is going to be a pentagon because it has 5 sides. So we call that a pentagonal pyramid. If you called it a pentagon pyramid, that's totally fine for today. It has 5 sides, and so what that means is it's going to have 5 faces around the walls and then 1 around the bottom. So it's going to be a total of 6. How many edges is that? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So a total of 10 edges. 10 edges. How many vertices? Just the points. 1, 2, 3, 4, 5, 6. Check it. F plus V is 12. 6 plus 6 is 12. 10 plus 2 is also 12. So great way to use Euler's formula to check your faces, edges, and vertices. Now, in class or posted on Google Classroom, you will have access to this video that is called the cross sections video. You will open that up and watch it. It's short. It's only like a minute and a half. Slicing three-dimensional figures, watch that. I will link that on our Week at a Glance, but that is what we are going to be looking at for cross sections. A cross section is going to be the 2D figure that happens. It's formed by the intersection of a 3D figure and a plane. So I always think about it like slicing a cake. If you were to slice a cake, what shape would be left on top after you sliced it or on the side? So I always think about my mom made a Barbie cake for me growing up, and so she had to slice a three-dimensional figure to make it flat in order to be able to have the Barbie stuck into that. And so if we were to take this shape, so what shape is this? This is a triangular pyramid because it comes to a point. If I were to slice that, what 3D shape would be left right here what 2D shape would be left when I cut this 3D shape? Let's go ahead and outline that. 1, 2, 3. This would form a triangle. When I slice this parallel to the base is a triangle. And so since I'm slicing it parallel to that, it's also going to form a triangle. So it's kind of like a stamp. My kids get stamps at school if they have a good day. And so it's what 2D shape would be left by that stamp if you were to put ink on wherever it got sliced. And so when we take a cone, so a really good way to think about a cone is like a party hat. If I were to slice it at the tip top of it and I were to slice it vertically, what shape would be left? What shape is going to be left on this? This is going to be a triangle. If I were to slice that with a ninja sword straight down the tip top of the cone, it would create a triangular cross section. And then if I were to take a can of soup and I were to use the can opener halfway down the can or somewhere in the can and it's parallel to the base, what shape would be left? What shape would get formed? What 2D shape would get formed? This would be a circle because it has a circular base and it's parallel to that. So it's just kind of like looking at, if I were to slice it this direction, what 2D shape would be left if I wanted to stamp it, okay? And that video will help y'all a lot on that. So we have our Google Sheet for homework. It is your 11.4 homework. Feel free to use these notes to help reference that, and y'all just come see me if you have a question. I hope you're having a fabulous day.